Hi, Assalamualaikum and a very good morning. So today we're going to do some tutorial discussion for chapter 13 and we're going to focus on the tutorial question 1, 2, 3, 4, 5 and 6 respectively. So without any further ado, let us start. So for tutorial question 1, we have to give the structural formula of the monomer for the following polymers. So the first polymer is shown as here. So we have to find the monomers. Okay, so as what you can see in the polymer here, a double bond is formed. So you know that the polymer will also the monomer will also contain the double bond. Okay, and you will expect it to have the addition reaction, addition polymerization lah. Okay, so the polymer will be the same as the monomer, which is CH. Okay, and then I will expect it to have double bond CH. Okay, and then I'm going to copy back again CH, CH2. Okay, and then here I will expect it to have my second double bond. Okay, and here going to be the single bond. Okay, so why am I saying this? Because I will this is my monomer, because my monomer going to be the same as polymer, but then you just put it as N here. Okay, and then when it undergo addition polymerization in the presence of peroxide, you will know that it will form a free radical where the double bond here, one is being used in order to make up a bond here, and the other bond going to be the other electron going to be used in to transfer the one electron to the next monomer. So one single bond here representing two electrons. So a half-headed arrow representing one electron is being transferred to the middle, and another one electron is being transferred in order to connect to the next monomer. Same goes to this reaction, to this double bond here. So one electron is being transferred to here, and another electron going to be transferred to the next part here. So as what you can see, as a product of the when the monomer going to react to one another, it's going to produce a polymer here. Okay, and the CH2 double bond CH here going to become single bond, and the middle here going to become double bond because one electron and one electron going to producing two electron, which referring to a extra bond here. And then this is going to be a single bond because it's going to break, and then the other one electron is used in order to make a bond in between the next monomer. Same goes to this side. Okay, so the answer here going to be as shown the structure here, which is the CH2 double bond CH, CH, CH2. Okay, so this is the monomer for the reaction. Okay, and now we move on to the question 1b. So 1b, we have C double bond O, CH2, 6 and H. So as what you can see here, it is a condensation polymerization. So why did I say a condensation polymerization? Because what you're going to do is the initial structure here will have a OH group, which is going to be a carboxylate, and then here NH here going to become NH2. Okay, so as what you know, one of the hydrogen going to be removed from the amino group, and the OH going to be removed from the carboxyl group. So H and OH going to be removed as water, and when a small molecule is being eliminated, you know that it is a condensation polymerization. So the monomer should contain the OH, and the NH here should have extra H. So it's going to become NH2. So you can written it as COOH, and then NH here going to become NH2. So here is the monomer. Okay, so monomer sebelum dia react, selepas react menjadi polymer, dia dah hilang OH dan H2. Alright, and now for structure of D. So for the polymer D here is the same as B here. So you know that the C double bond O should consist of OH, and C double bond O here will also have OH. And then for the amino group, it should have NH, NH. So you're going to have NH2. Same goes to this side. Okay, so for the monomers, we're going to have two different types of structure. So first we have the one for benzene dicarboxylic acid, where C double bond O, OH. So we need to include the OH. Same goes to this side here. Okay, and then the one for benzene diamine will also have their hydrogen back. So we're going to become NH2 here, and also going to be NH2 here. Okay, now for the structure of E. So the polymer E here, you can see that it's going to have single bond and single bond. Okay, and single bond here. So you know that it is an addition reaction, addition polymerization. Okay, the above here is condensation. Okay, so you know that when addition, you need to have double bond. So the most logical double bond that you can get is to have it here. So what you're gonna get you're gonna get CH2 double bond CH and COCH3 C double bond. Okay, so the free radical reaction happen here, where in the presence of peroxide, it gonna opens up one electron to this side and one electron on the other side. Okay, and this is why it gonna have a connection here, and it also have another connection here, so that it can connect with another monomer. And from a double bond, it gonna become a single bond. So the most logical answer gonna be this structure here. So you can draw it nicely as here, which is CH2 double bond CH bonded to COCH3 and double bond here. Okay, so that's for tutorial question number 1. For tutorial question 2, we have to predict the structure of polymers that are formed by the co-polymerization of the CH2 double bond CHCN and CH3 CH double bond CHCl. So here contain a double bond and here contain a double bond. So you know that it is an addition polymerization. Okay, so now we're going to predict the structure of the polymer. So in order to do this, you can draw the structure first. For example, CH, CH, double bond, C, CN, H. Okay, and then you're going to react that with C, double bond, C, and then the above here is CH3, and then C is bonded with hydrogen. Meanwhile, the C here is bonded with Cl, H and Cl. So Cl and H. Okay, so you know that they will undergo in the presence of peroxide. Okay, so in the presence of peroxide, the double bond gonna be broken, and then one electron is being transferred to the middle, and the other one electron going to be transferred in order to make an attachment. Same goes to this double bond here. One of the electron is used in order to make bonding, and the other electron is used to make an attachment. So as a result, you're gonna get carbon and carbon single bond gonna be attached together. CCN dengan CCH3 gonna bersambungan. Okay, so what you're gonna get is CCNH, which is CCNH, gonna be attached with the CCH3 and H here. Okay, and at the same time, one of the electron from the double bond gonna be transferred in order to make an attachment here. Okay, same goes to this side, where it's gonna use in order to make bonding with the next monomer. Okay, and the double bond gonna becoming a single bond here. Same goes to this side here, where it's gonna become a single bond. Okay, and the double bond gonna be produced here. Okay, and then this might be one of your possible structure, but let's say, okay, let's say if you want to change your structure, for example, sir, can I react that with this carbon here? Okay, the answer is yes. So if you want to put your Cl here and then your CCH3 here, it is also okay. Okay, because the radical can also react from this side. So Tadi Cl adalah di sebelah kanan, sekarang Cl ni adalah di sebelah kiri. Seolah-olah kita pandang dia dari sebelah sini. Okay, this one is carbon number 1 now. This one going to be carbon number 2. Okay, so if you were to do like this, masih cara yang sama. So what you're going to get is the carbon-carbon single bond connecting CCN dengan CCl. Okay, so you will also get this answer here. Just now, you will get this answer. So actually, both of the answers are accepted, but this one is the more common answer lah. Okay, because it is easier to see. Okay. Okay, so this is the answer for first possibility, and this one is the second possibility. So both are accepted. Now we're going to do the polymers for the part B here. So we have our C6H4, and then it's going to having carboxylic acid and carboxylic acid. Okay, so hexandioic acid, and then they're going to have a structure here, and then it is attached with hydroxyl group and also hydroxyl group. So you don't have to worry about the naming, because what's important here is you need to know what is being eliminated. So from here, there doesn't have any carbon-carbon double bond. So you know that it will undergo condensation, because it's going to eliminate small molecule. Condensation, polymerization. Okay, so in the condensation polymerization, what they're going to do here is that the C double bond O, OH from the carboxylic group, and here is alcohol. So what's going to happen here is that the OH going to be removed, same goes to the hydrogen here. So what they're going to form is an ester bond where the C double bond O and oxygen going to be connected together with the alkene chain. Same goes to here. Okay, at the same time, the one at the back, which is OH here, will also be removed because it's going to attach with the next molecule. Same goes to this part where in this OH group, we're going to remove the hydrogen. Okay, so we're going to end up with O and bracket. Here, going to end up with C double bond O and bracket here. And then for our polymer, we need to write the N. Okay, so remember to include the N and to include the N at the end. Okay, so our answer going to be looking something like this. So what we're going to get is C double bond O, C6H4, and then C double bond O again, and then we're going to make an ester bond. So you know that it is a polyester. Then CH2, CH2, 3, and then CH2O, and then we close it with an attachment with a bracket and include the N. Okay, so this is our polymer. Now for tutorial question 3, we are given the structural formula of the 3 organic compounds as shown. So let's say for the structure number 1 here, you have a carbon-carbon double bond, which is CH2CHCl. And then for the structure number 2, you have an acyl chloride here, which is C double bond OCl, C6H4, C double bond OCl, and the structure 3 here, which is ethane 1,2-diol. Okay, because it have 2 alcohol group. Okay, sorry, 1,2-ethane-diol. Ethane-diol. Okay, so we have to choose an appropriate monomer that can undergo addition polymerization and the condensation polymerization. So for addition polymerization to happen, we need to have carbon-carbon double bond. Meanwhile, for the condensation polymerization, we need to eliminate small molecule. Okay, so for addition polymerization, what we need is a carbon-carbon double bond. So the only structure that have a carbon-carbon double bond is the structure number 1. Okay, so what we can do is that the structure number 1 gonna be reacted together in order to form a monomer. So a lot of the structure number 1 here. So what we can say is that the structure number 1 will undergo addition polymerization, and then what we're gonna do is we can also draw the structure of the polymer. Okay, let's say this one will be connected to this one, and this one going to be connected to the other one. And then what we're going to get as the polymer is, because double bond just now going to be broken apart, So it's going to become single bond H, Cl, H, H, and then it's going to make a new attachment here, and then another attachment here, and then we're going to close the bracket and put it as N, which refers to the polymer. Okay, so for the polymer, we can write it as like this, as the answer here. Okay, now for the condensation polymerization. So for the condensation polymerization, as I mentioned, it needs to eliminate small molecule. So you need to react your structure number 2 here with the structure number 3. Okay, this is because in the structure number 2, you can eliminate Cl. In the structure number 3, you can eliminate hydrogen. So what you're going to eliminate is your HCl. Okay, so you can make it as C double bond O, Cl, C6H4, C double bond O, Cl. So when it is being removed, okay, this one is also removed. This is going to create an ester bond. Okay, O, because hydrogen is being removed. You're gonna draw back the structure, which is CH2, CH2, O. Okay, and then you're gonna close the polymer and then label it with N. So what you're going to form here is an ester, which is a polyester. Okay, so what you can say here is that the structure 2 and 3 can undergo condensation polymerization, and the structure going to look something like this, which is C double bond O, C6H4, C double bond O, O, CH2, CH2, O again, because the end part here is also removed. Okay, and Cl here and Cl here is also removed. And what we're going to eliminate is HCl. Okay. Okay, so that's all for question number 3. For question number 4, we have to draw the structural formula for the monomers of the given for the polymer given below. So we have our polymer here, and then we need to predict our monomer. Okay, so as what you can see here, it becomes CH, CH2, and then it's going to attach with C6H5, which is the phenyl. So your polymer, ini polymer kamu, it has a single bond. So you know that your monomer gonna have a double bond. Okay, double bond dia datang daripada sepatutnya datang dari sinilah, because it gonna break apart to this side and also break apart to another side in order to make another attachment with another monomers. So what you're going to expect is the benzene ring attached with CH and CH2. So here refer to a styrene, and here is a polystyrene. Okay, untuk monomer tak perlu ada N. You just write it as one time because it is mono, refers to one. Okay, for the structure of B here, we have to also predict the monomers. So in this case, the best way that we can look at it is to look at the attachment here. Okay, so you know that it's going to have NH, C double bond O on this side. So if we're going to break them apart, the NH part here going to get NH2, and this part here will also get NH2. So what we're going to get is CH2, NH2, CH26, NH2, and the C double bond O here will get its OH back. Okay, and same goes on the end here. You're gonna get their OH back. Okay, because OH and hydrogen can be removed to make water molecule and in order to make a NMAT bond. So as for the monomer, you're gonna get this one monomer and this second monomer here. Okay, so first you're gonna get 1,6-diamine, 1,6-hexadiamine, and then you're gonna also get your structure here, which is the CH24, C double bond OOH, and C double bond OOH here. Okay. So now for question C, um, it is almost similar to the question B here. So the same method, because you know that you have your amide bond, okay, you know that you have your amide bond, so you can break the amide bond, and then the NH here going to become NH2, and here will also become NH2. Meanwhile, the C double bond O here going to become C double bond O OH, and same goes to this side, which is C double bond O OH. So you're going to get one polymer here, one monomer here, and another monomer here. So you're going to get 1,4-benzene diamine, and you're going to get 1,4-benzene dicarboxylic acid as your monomer. Okay, so you need to write both. Same goes to here. For addition reaction, you write it as one time is okay, because it does not, because it involves the same monomers. Okay, so that's all for tutorial question number 4. So for tutorial question 5, we have to define the condensation polymerization. So condensation polymerization really means it is a chemical process in which two monomers gonna react together in order to form a larger molecule, and it gonna eliminate a smaller molecule such as water, methanol, and hydrochloric acid. Okay, so that's for tutorial question 5a. For tutorial question 5b, when a compound P, which is the C8H10, is refluxed with acidified potassium permanganate solution, the product is Q, which have a molecular formula of C8H6O4. When Q react with methanol in the presence of an acid catalyst, compound R, which is C10H10O4, is formed, which is a monomer of dacron. So we have to predict the structure of P, Q, and R. So P, Q, and R. Okay, as what I have taught you before, we need to come up with our planning or an idea first. So let us read the question again. So when a compound P, which is having a molecular formula of C8H10, is refluxed with acidified permanganate solution, which is KMnO4 at acidified condition at high temperature, what we're going to produce is a compound Q here, which has a molecular formula of C8H6O4. And then this Q here gonna react with methanol in the presence of acid catalyst. Okay, and this gonna produce compound R, which has a molecular formula of C10H10O4. Okay, in which this structure here is the monomer of a dacron. Okay, and then we have to predict P, Q, and R. So in order to do this, you have two strategy. First, if you remember the structure of the dacron, the monomer of the dacron, you know that you can start with that first. Okay, so for example, the monomer of dacron, if you were to remember or memorize that, you know that dacron gonna be the combination of two monomers. Okay, two different monomers. So the first monomer gonna be the etenediol. So you have CH2, CH2, OH, and OH. So it is 1,2-etenediol. Okay, and then the other structure here gonna be the dimethyl terephthalate. Okay, so you can look in your lecture note. So it's gonna be like C double bond O, CH3, and C double bond O, CH3. So this is a dimethyl terephthalate. Okay, so if you were to remember the monomers of dacron, you will know that it only consists of these two types of monomer. And looking at this molecular formula, you know that the answer gonna be this one. Okay, and then you can go reverse way. Okay, that may be the first strategy. If you don't remember the structure, what you can do is you can start up with the P first. Okay, so you know that C8H10, you know that it is an alkane because it only consists of carbon and hydrogen. Okay, but you know that it cannot be a straight chain alkane like this because the number of hydrogen is not tally with the carbon here. Okay, kalau alkane biasa dia akan jadi C8H18, right? Kalau alkene pula dia akan jadi C8H16. Okay, ni alkene. Okay, so you know that it cannot be something like this. Okay, so you know that by having C8H10 here, a benzene ring gonna exist. Okay, because the benzene ring is already took up C6H6. Okay, so the balance here that you have is C2H4. Okay, and the C2H4 here actually can make an attachment. Okay, so let's say if I make two attachment here and here, the number of hydrogen gonna reduce, right? Become C6H4. Okay, because we're gonna have 1, 2, 3, 4 hydrogen. And then here gonna be C2H6 because I need to total up it to become C8H10. So C6 campur C2, C8, H4 campur H6, H10. Okay, so I know that I got C2H6. So C2H6, if I were to make two attachment, because polymer is usually on the right hand side and the left hand side, so you know that I will get CH3 and CH3. Okay, so I'm going to put it as CH3 and then CH3. Okay, so this is going to be the structure for P. Okay, and then you may come up with different strategy. Maybe you will say that, sir, can it be like this? Or sir, can it be like this or like this? Okay, so for P, only this structure is accepted. Okay, because you know that polymer, it needs to be continuous on the right hand side and on the left hand side. If like this, it is very close by together and it's going to create a steric hindrance. And that is why polymer is usually 1,4 dicarboxylic acid and so on. Okay, kalau nampak dalam lecture note, dia sentiasa berjauhan antara satu sama lain dan dia selalunya di kiri dan di kanan. Dia tak bolehlah satu sebelah-sebelah ataupun di sini dengan di sini ke, tak boleh. Okay, and for this structure, for example like this, okay, we never seen this in our syllabus. Okay, so we don't do any polymerized structure from here. Okay, so this one cannot be the answer. This one also cannot be the answer if like this and like this and like this also cannot be the answer. So the most logical answer gonna be 1,4 dimethyl benzene. Okay, so that's the idea. Okay, let me rub it off again. So for P here, if I were to draw it nicely, I will get something like this, which is 1,4 dimethyl benzene. Okay, and you know that I'm gonna have methyl group and methyl group here. So when the methyl group undergo oxidation, what I'm gonna get is a carboxylic acid. So I'm gonna get carboxylic acid on this part and carboxylic acid on this other part. Okay, and then this is gonna be the structure Q here, and then this carboxylic acid, which is C double bond O OH, and the C double bond OH can react with the methanol here. So methanol here gonna act as an okay. So when we have our carboxylic acid and we have our alcohol, it can react together and remove OH and H. So they will undergo the process of esterification. Okay, and the esterification is verified, diperakui dengan adanya acidic catalyst. Okay, so we're going to eliminate OH and we're going to eliminate hydrogen, and what we're going to get at the end is the C double bond O connect with OCH3. Same goes to the below part here. Okay, so it's going to be C double bond O dash OCH3. Okay, so that's going to be the structure of R. Okay, and if you were to compare the structure that we have got for R, which is the dimethyl terephthalate, it is consistent. So if you were to look at your lecture note or you happen to memorize the structure, you're going to get that it is the same structure as what we got from here. Okay, so that's all for the tutorial question 5b. Now we move on to the tutorial question 6. So for tutorial question 6, A, we need to draw the structural formula of hexane diuic acid. So hexane diuic acid going to have 6 carbon, which is 1, 2, 3, 4, 5, and 6. Okay, and then it's going to be attached with the carboxyl group on both ends, OH here and OH here. Okay, so you can draw it like this, or you can also draw it in terms of the content structure, which is COOH, and then you have 1, 2, 3, 4, CH2 times 4, and then you have COOH here. Okay, so that is why you get COOH, CH2, 4, COOH. Okay, so you can also draw it in terms of this condensed structure if you find it easier for you. Okay, and next you need to draw 1,6-hexane diamine. So the same thing, 1, 2, 3, 4, 5, 6, and then make an amino group, and then make an amino group here. Okay, or you can also write it in terms of the condensed structure, where you can say that it is CH2 6, 1, 2, 3, 4, 5, 6, and then it's going to have NH2 at the end and NH2 on the other end. Okay, so this is going to be 1,6-hexane diamine. Okay, and now for tutorial question 6b, we have to write an equation for the reaction between both compounds to form a polymer. So we're going to react our hexane diuic acid, which is a certain amount, and then we're going to also react our 1,6-hexane diamine, which is a certain amount. Okay, and then they're going to react together, in which this will undergo condensation polymerization. Okay, so condensation polymerization, as what you have learned, it's going to eliminate small molecule. So in this case, what we're going to do is we're going to eliminate OH here, and then on this part we're going to eliminate hydrogen. Okay, so what we're going to remove is H2O, and then the C double bond O and NH going to be combining together, and this happens for this end also. So they're going to lose one hydrogen, so we're going to become NH, and here going to lose OH, so it's going to become C double bond O, and then it's going to make an attachment. Same goes to this side. Okay, H up here and then make an attachment. Okay, so what you're going to get is to be something like this, where the C double bond O from this side and NH going to be combining together. Okay, and this is an amide class of compound. Okay, and remember, you need to include the attachment and attachment here, as well as remove the hydrogen and OH at the end. Okay, and for polymer, you need to include the number, so do not miss out this. Okay, now we're going to do question C, where we have to name the functional group of the polymer found in B. So functional group. Okay, so if you write amide, okay, so this is the functional group. If you write amide, then it is wrong, because amide is the class of the compound, and it is bonded by the amide bond. However, the functional group here, as what you have learned in the chapter 4, it is a carboxamide. Okay, so be very careful. Okay, you need to know the functional group is different from the class. Okay, and now for the structure of D, you need to write the repeating unit of this polymer. So basically the repeating unit is the same as the polymer. Okay, sebenarnya sama saja. You just copy back the polymer that you get, but then you need to remove the N. Okay, kat sini dia tiada N. Itu sahaja bezanya antara repeating unit and the polymer. Okay, and now E, we need to give the general name of this polymer. Okay, in order to give the general name of this polymer, we need to look at our monomer here. So it consists of 1,6-hexane diamine, and here basically also consists of 1,6-hexane dioic acid. So 6 and 6, so it's gonna be 6,6 nylon and nylon 6,6. Okay, so this only asks us for the general name, not the IUPAC name. Okay, so the answer is only one, nice, nylon 6,6. Okay, and then for last question, which is 6F, we have to name the type of the polymerization. So the type of the polymerization here, because you eliminate small molecule, which is water, so it's gonna be a condensation polymerization. Okay, so I think that's all for today's video, and I really hope that you enjoy all the videos that I have made for this semester. Thank you for watching, and inshallah we'll meet again some other time. Okay, assalamualaikum and goodbye for now. Bye.